Now we want to take a look at how to use those properties to simplify radical expressions. In example 15, we have the square root of 9 times t to the 12th power. Since we have two factors, values being multiplied together, we can use the properties that we just established to rewrite this as the square root of 9 times the square root of t to the 12th power. The square root of 9 will give us 3, and then we can rewrite the square root of t to the 12th power using exponents as t to the 12th to the 1/2 power. This allows us to see things in terms of our exponent properties, specifically the power-to-power rule, meaning we can rewrite this as 3 times t to the 12th power times 1/2, or t to the 12 times 1/2 power, which will give us a final answer of 3 times t to the 6th power. In example 16, we have a similar problem, but rather than being written with radicals, this is written with an exponent. Since we again have factors, values being multiplied together, we can break this up into the product of two separate values raised to the same exponent, meaning we can rewrite this as 4 to the 1/2 power times a to the 12th to the 1/2 power. If it's helpful to see it, we can rewrite 4 to the 1/2 power as the square root of 4, which will just be 2. And then we can use the power-to-power rule to rewrite the second factor as a to the 12th times the 1/2 power, which will give us 2 times a to, again, the 6th power. In example 17, we have something a little bit different. We need to make sure we pay attention to the fact that we have this plus, this addition operation between those two radicals. That means that we can't combine those using the properties that we've established. Instead, what we'll do is look at tackling the first term and the second term separately, looking at what we can reduce and simplify. In the first term, we have 2 times the square root of 16x squared. We can break that into the square root of 4 times the square root of x squared. And then we have plus the square root of 36, which will just be 6. Simplifying this will give us 2 times the square root of 4 will be 2. The square root of x squared, which is x squared times 1/2, and still plus 6. Or more simply, we'll get 4 times x plus 6 as our final answer. And I'm sorry, I just realized I jumped ahead. That should actually be the square root of 16. I completed that square root in my head as I jumped forward but didn't write the right thing, which would make the square root of 16 equal to 4. And then when we multiply those two values together, we would get 8x plus 6. In the last example, we have the opportunity to use the quotient rule for simplifying square roots, meaning we can rewrite this problem as the square root of 4 times w to the w to the 7th power, all over the square root of 64 to the w power. We'll evaluate this problem in this manner, but I'm going to let you know that this is actually the more complicated way to approach this problem. We'll see why that is, and then we'll take a look at the simpler approach. The first thing we can do is simplify just what we have in the numerator. So we would break this up into the square root of 4 times the square root of w to the 7th power, which would give us 2 times the square root of w to the 7th power. Similarly, in the denominator, this would become 8 times the square root of w. Using the same techniques that we used above, we can rewrite this as 2 times w to the 7/2 power, since that's w to the 7th times the 1/2 power, over 8 times w to the 1/2 power. And now to simplify those exponents, we would subtract, which would give us 2 over 8 times w to the 7/2 minus 1/2, which would reduce to 1/4 w to the 6/2, or 1/4 w cubed. That approach completely worked, got us to the right final answer, but required us to use a number of different properties. An alternate approach to this problem would be to change that very first step. Rather than using the quotient rule for simplifying square roots, instead what we'll do is look at first simplifying what's under that radical. W over 64 would reduce to 1 over 16, and w to the 7th power over w to the 1st power would reduce to w to the 6th power. In this approach, we haven't done anything with the radical. We've just reduced what we could reduce. Now we'll come through and apply that square root, which will give us in the numerator w to the 6/2, and in the denominator the square root of 16, or 4. And then we can reduce what we have in the numerator to be w cubed over 4, which is the same thing, just written a little bit differently than as 1/4 times w cubed. So with these radical properties and other properties that we'll introduce, sometimes there can be multiple approaches to a problem. One method might be simpler than another, but what's important is that we just make sure our steps along the way all follow those different rules and properties.